Okay, so the last time, if you remember, we go from the beginning quickly, then just do a review. Yeah. All right. So finite state machine, we learn about a state table and a state graph. So you remember we have this table, state table, in which we have the, go back up a little bit. All right, we have this next state, we have the, let me see if I can annotate a little bit. There's no annotation here, but anyhow, okay. Shiham will help me show with the pen or with the arrow, yeah? Okay, so we have the next state on top. Then we have the current state on the left. So this current state will give the initial state, yeah? So we call it S. So in this case, we call D, E, F, B as S, right? And then the next state gives us the current input, and underneath that should be 0 and 1. So you should add the current input, missing the 0 and 1 under the current input. So under the next state, it's still the elements of the state. So you see that there is a D, E, F, B underneath the next state, yeah, under current input. And we also have the output. So in this case, the state is D, E, F, B, the input is 0, 1, and the output is also 0, 1, right? Then next, we have the state graph, all right? So according to the state, which is D, E, F, and B, so the first vertices, the first vertex, Shiham, it's a D slash the output, right? So the second one is E slash the output, depending on the table, F slash the output, and B slash the output. And then depending on the next state, we draw the edges, yeah? So depending on the state, if you refer above, then you can go through, yeah, D, you put under 0, you go to C as an example. So from D, there is a 0, you go to E, sorry, yeah? Okay, then that's the arrow. From D, under 0, you go to E. Okay, next. Okay, go next. All right, so we look at the initial state, and initial state depending on the set. If the set are letters, then you show alphabetically order. So you will show the first example is BADEC. So the first letter will be A. If it's numbers, then the number accordingly. If there is a 1, so it's 1. And the letters again. And if there is a subscript, it depends on the subscript. All right. Then we learn about the output of the sequence. When you are given the input on top, right, the first row is optional, in which the time we start from 0 until the end, but we start with the first row, which is the input, right, accordingly to the question, 0, 0, 1, 1, 0, 1, 0. And depending also on the state table. So the first one, you should put the first initial state. That's why we put a B, and the output for that is again optional. Then you go to input, and then the state, and then you go to the right, and you go down. So we did that before. Okay, next. We have seen the state graph also, all right, and the state table. And I give you another example here. Okay, now next to the next session. Okay, this is called a homomorphism of finite state machine. Now, you remember the homomorphism from the previous chapter, right? If you have a semigroup and to another semigroup, or you have monoid to another, or group to group, a homomorphism from one to another is given by the formula. right? F of AB is FA, FB, right? Maybe Shiham can write it just on the right. Yeah, F of A, and I put a star if the F is from, call it F is from G star to H hash, right? So F of A star B is equal to F of A hash F of B, depending on the operation. So this is actually the definition of a homomorphism. All right. So for this particular finite state machine, we will have two machines. All right. So call it, the first machine is M and the second machine to be M star. So you will be given S and S star, right? I and O, you will see that it is same I and O. You cannot change the input and the output, right? And also you will have the next state function and the output function depending on the machine. So input and output stays the same. All right. Now you have these two properties, yeah? The F naught S has to be equal to, okay, the first characteristic, if you can see that property, F naught S is equal to, you have an S, and then there is a G, which is a homomorphism, okay? So from S, you have the image 2, you can draw that down there, Shiham. You have the machine S from here, and you have a G to S prime. Okay, so that is S, and the mapping is G, and the right-hand side is S prime. So inside the S, there is a little s. Okay, so in the right-hand side, there is a GS. Okay, so you will have this S goes to GS. We cannot draw this here, but this machine, there is also the F star, okay, for that machine. Since we already have in S prime, look at the M star in the machine. So this S prime is in M star. And how do you go to M star? There is a homomorphism. Call this homomorphism down there. There is a homomorphism F naught and F star. So homomorphism F star, putting in the GS into S. All right, it's quite hard to imagine, but I will show it with the example. Okay, go down a little bit. Okay, so you remember the next state you have in the table, right? There is the direct product. You need S on the left, and you need the I up there to get the next state, right? So that is why we have S cross I. Now under G, when you look at what Shiham draw that time, under G, S go to S prime. So we can have this mapping G from S cross I to S star cross I, all right? So this is the homomorphism. And the normal F naught or Fs give us in the state S cross I goes to S. On the right-hand side is the M star, the machine M star, the normal Fs prime, right? So down there, you see that S also have the homomorphism to S star. Okay, this is actually the history and the background of how we create this homomorphism between two machines. All right, so we go to the example. All right, so this is you have two machines, yeah? Okay, now the first machine, you can already write your S, right? 0, 1, 2 is given down there, yeah? Okay, and the output of 0 is 0. The output of 1 is 1 on the right, yeah? And the output of 2 is 1, right? And inside the next state and the current input, we see that if we have Fs 0, 0 will be 0, 0, 1 will be 1. It's a little bit confusing because they're all numbers. before I use letters, right? So this can be all numbers. The next state, the state table has a different, state, current state. The current state for the next table is just A and B. Okay, so the next state also with A and B underneath the table. But we have to have the same input 0, 1 and the same output 0, 1. This is given as two machine. Now, how do we get the homomorphism in between these two machines? Okay, I define this homomorphism because show the two tables. Okay, you have to map the state with the same output, right? So you can definitely see 0 with the 0 output is mapped to A with the 0 output. Okay, so you match up. 0 with the 0 output will be mapped to A with the 0 output. Little bit down, little bit. Oh, okay. Okay. Now with the 1 output, right? The first machine, yang color-color macam best lah eh. The first machine, two current state has output 1. Yeah. So this 1, 2, we map to the second machine with the output 1, which is a B, right? So you have that homomorphism already. Remember the one that you have draw in the first place, S goes to S prime with G. So now we have that G down there. So Shiham can draw another one down there from S, which is 0, 1, 2, to S prime, AB, and match the elements with the same output. So 0, 1, 2 with AB. Okay, so 0 is mapped to A, 1 and 2 is mapped to B because they have the same output. All right, so this is how we map the Z from the first machine to the second machine. Okay, okay so far? Yes, no? Type? That's why I don't like to share because I won't see you. Now I can see you because somebody else is sharing. Okay, good. I see Alia already give a jempol, a thumbs up. What about the others? Okay. Okay, so far, yeah. All right, next. Okay, so you have this condition, right? Condition 1, remember just now I mentioned that how do we check F naught S is F naught star of GS? You have to check this. If this is not applicable, then our G is wrong. All right, so see the rightmost side inside the parentheses, not that one, in the condition, right? In the condition, you see the most inside is GS, right? S, okay, the inside is S, yang paling dalam sekali ya, inside the parenthesis is S. That is why the first row, the first column is a capital S. Sorry, that is actually S in capital S, right? Put S in capital S in the first column, right? In element of, you can put little s, element of capital S, right? So because of the first condition, we need to see this whole thing. So you will start from the right handmost. So S inside just now come from the first table. So you put 0, 1, 2. Next, you want to see, I normally will go to GS first, right? And then I will go last to F naught S, but this is okay. Yeah, that is okay. We start from that, then we go to the left side. Now go to the table. Remember, we have to find the output. Go to the first table, right? So that output 0, 1, 1 is F naught S. So copy that put there down 0, 1, 1. Okay, Shiham, you highlight 0, 1, 1 underneath F not S. So that comes from the first table, yeah? The output of all the S accordingly to the first condition. Okay, now we go to the right-hand side of that condition 1. Okay, this is from first table, last column for the output. Now GS is from our homomorphism. Yeah, so you look at the homomorphism up there, 0, 1, 2 goes to A, B, B, right? So you put that in that column, right? GS, yeah? So you can highlight that column, come from the G that we defined earlier, up there. Yeah, from the G that we defined earlier. Okay, now we have to go back to the second table, okay, and look at the column down there just now, right? We already have the GS A, B, B, yeah? Then you have to see the output, F star output of A, B, B. So you look at the second table and see the output up there, right? The output of A is 0, the output of B is 1, right? So you put that in the table. The output of 0 is 0, the output of 1 is 1. Oh, this is, yeah, the output of 2. Oh, sorry. The output of A, GS, yeah? The output of A is 0. The output of B is 1. The output of B is 1. It's the same thing, all right? The output of A is 0. The output of B is 1. Okay. Now, condition 2 is a little bit complex. You have to show this G of the next state of the first table of Si. Remember, you have 3 of those and you have 2 of this. So inside we have 6, right? Okay, you have to check this for every pair in the first table and see the next state. Okay, that is the left-hand side and find the G. All right, and the right-hand side, you have to take the S first and like put the G of S, comma the I, then take the next F star. All right, so this condition have to be proven the same. You do it one by one from the table. Okay, so remember, yeah, we need Si. So go to the first table, Si. Okay, so you will have 0, 0. You just show it, Jam. Current state, current input. 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. So you put that in the first column, right? So go down to the first column. 0, 0, 0, 1, 1, 0, 1, 1. There's a 2, 0 and 2, 1. So 1, 2, 3, 4, 5, 6. Okay, so I go first row, right? Second row, go back. Okay, now quickly you can copy paste the inside, the next state. 0, 1, 0, 2, 0, 1, right? 0, 1, 0, 2, 0, 1. Okay, go back down. It'll be 0, 1, 0, 2, 0, 1 in the second column. You show the second column. Yeah, that comes from the inside of the first table. Okay, now from this, you remember our G? Our G send A to 0, send, show the G, show the G send 0 to A, 1 and 2 to B. Okay, go back down. Okay, so the G sends 0 to A. So from second column, you get the third column. Yeah, 0 to A, 1 to B. 0 to A, 2 to B. 0 to A, 1 to B. So that is how you get the third column. All right. So you see, the key is if you remember the condition, then you can easily find the detail of the column. All right, now we go to the right-hand side. Okay, in the right-hand side of the condition 2, show it, Shiham, up there. In the right-hand side of the condition 2, we have to find the inside first. Yeah, GS, you need an S, right? So you look at on the leftmost hand side, that is your S. You have to follow that because you are doing it for every pair, okay? And with that S, we want to do GS, right? And GS send 0 to A, 1 and 2 to B, right? So the first column, S is 0. The fourth column, GS is A. The first column, S is 0. The fourth column, A. Then you get 1 goes to B, 1 goes to B, 2 goes to B, 2 goes to B. So Shyam, you have to show from the first column to the fourth column, right? And you just copy the second component because it's the same I. That is how you get the fourth column from the first column by applying G to the S, right? Okay. Now, next one is the next state using the second machine. All right. And this one you have to follow. It's not like before. Before it's very nice. We do it to the according, right? So you have to show the second machine, Shiham. So we can see, for example, A naught, right? A naught is A. A naught is A. So you put A down there. A naught is A. Then you check A1 is B. A1 is B. So that B you put down there, right? B naught is A. B naught there. B naught A. B1 B. So those four things is repeated. So you can put it over there. And then you have to check whether the third column, is it the same with the last column? Try to shade, if you can, that column. Highlight the column of the third column and the last column. Yeah. So if you are given, this definitely will be in your final. If you are given to show whether this condition is satisfied or not, don't forget to somehow highlight or lorry, yeah? And then to show at the arrow down there, maybe you put these two together that they are the same. The condition 2 is satisfied. Yeah, must be the same. So you check. If this is okay, then this is homomorphism between the two machines. Okay, if this is not satisfied, meaning this is a wrong G in the beginning. Yeah, but if you follow through, it's straightforward. All right, this is to show the two condition. Okay, is it okay? Okay. Tak ada pun yang okay ni. Alright. Nobody says okay, so it's not okay. Okay. Type lah sikit kat chat. Okay. Alright, maybe you are still writing. Is there? Yeah? Okay. So now for this first example, you are given the two machine, right? Normally, we have to find the quotient machine. Okay, we have to find ourselves. You're given just one machine. Okay, so now the quotient machine means you are given M and M star as before. Okay, And with this binary operation G, we want to find the equivalent relation of, you remember the equivalent relation when you learn in that chapter? And from the equivalent relation, we can have equivalent classes. So you go down. So the new machine, we call it M stroke G. Okay, like the quotient. You remember when I mentioned about the quotient group, we have G mod H, in which H is a normal subgroup. So in this chapter, we have a new machine with the assigned homomorphism G, and we call it M star. So M star is actually equal to the quotient machine. And we will see that the state that we group together, we will put them in what we call an equivalent class later. Just now, we just put A goes to 0, right? 0 goes to A, 1 and 2 goes to B. In this part, we will put together the one that we have more than one. Even one, we just have only one equivalent class. Okay, I think it's better to show with an example. All right, so the first machine will have the state in the beginning. The second machine will be including the equivalent classes as the state. Yeah, okay. Now, using the previous example, we already have G as a homomorphism. Now, this M star in the previous example, we will call it M stroke G, the quotient machine. And if you see the one in the beginning, we put the one with the same output as one equivalent class. Yeah, that's why before we put 0, right, with the output 0. So put that as one equivalent class. And the second one, that is a comma missing, yeah, 1 and 2, you can call it equivalent class bracket 1 or bracket 2. But we normally will use the first number, right? If you put 2, even is okay. But we normally will choose one representative and we put the smaller one, smaller in the sense A or the first letter. Okay, so when we look at the second table on top, you see just now we have AB, right? The M star, the machine on top. Okay, that machine, you see you have A and B. Now we want to change that A and B into the equivalent class from the top. So A will become bracket 0 and B will actually be bracket 1. Then we have the next example that shows that. Okay, you see now, but you have to do it carefully. So when you match up, they are okay. The A is actually the equivalent class with 1 and 0 and 0. All right, now the next one is how we do the homomorphism. So the first M is 0, 1, 2, and then we get the M star into the one that we did before. 0 goes to A, 1 and 2 goes to B, and then we change the A into 0. Shiham, there's a typo, B to 1 on the rightmost hand side. Okay, and that is how we move straight from the beginning. We call it G bar. Yeah, the one inside what's missing is a G. Okay, from the left to the middle, the mapping is the G. So you can add that too. All right. And the last one, we don't call it anything. We just did. Okay, hold on. Okay, all right. So, okay, this theorem, yeah, homomorphism of M and M star. This is put as what I said before, but it's put formally as a theorem. Let G be a homomorphism from the first machine to the second machine M star. And the homomorphic image of M star, the one that we put before, right, on top in the middle, is isomorphic to the quotient machine. Yeah, the quotient machine. So what does it mean by a quotient machine? Okay, if you are given a machine M, down there, the definition 7.3 is a finite state machine, then the state S can be partitioned so that a new machine can be defined using the partition block as a state. Then the new machine, we call it a quotient machine. And how do we partition? We partition using the same output. Okay. Then we go to the next definition. Okay. This is all formally defined. I have mentioned all of this, but this is how it is formally defined. Given two finite state machines, M and M star, you see you have two states, S and S star. I and O are the same. They have to have the same input and output, but they have the different, the function, right? The output function may be different, and also the next state function, depending on their table. Now, this is the word. M is said to simulate M star. The first machine is said to simulate M star. If there is this function G, which before we call it a homomorphism, from S to S prime. G is from S to S prime. That's typo. Okay, so in such that you have that condition, it looks a little bit complex, but we will figure out, yeah, the condition. So now this has to be true if there is equivalent state for all, and they have all the same output for all the input. So the process has been explained before. Now they just put it as a definition. All right, go to the example. Okay, now you are not given a table, but you are given a state graph. All right, so let's try to write the table. You have a blank paper. Maybe Shiham can squeeze over there a little bit. Okay, or you can add a new one. Okay, draw a table, yeah? With the state on the left, with the current state, and the next state with the input and the output. So you see the current state from the vertices 0, 1. So you put that on the left 0, 1 slash the output. So you put that on the right. And then you look at the edges, right? The edges 0, under 0 and 1, it is 0. So you go down both 0 and 0, all right? Next, you go to the other one. Under 0, it goes to 1. Under 1, it goes to 0. Right? So you put 1, 0. Yeah. Then you do the same thing to the second machine. All right. So you go to the vertices. A and B, right? So you put A and B on the left. Then you slash 0 and 1. So you put that 0 and 1 on the farthest right. Okay. Then you look at the edges. So under A, go input 0, A goes to A. Input 1, A goes to B. So you put A, B in the first row. Next, you go to B. B under 0, it goes to A. B under 1, it goes to B. So you put A, B. So you are done. But this one, you see that they are very, very similar, right? They have 2 states for the first M. There are 2 states for the second M. So the output also, one has output 0, yeah? Go back to the question. I actually wanted one to have, yeah, because I want to show, okay, this one, you see, although they have quite similar, but you don't have the same output, right? The output state, the output set is just 0 for the first one. So it says down there, M star cannot simulate the M. There is no state in M with output 1. Okay, so in this case, then you cannot put the homomorphism in between the two. So come the next definition. They are equivalent if each other they can simulate the other one, right? So this one cannot match. You go to the table just now, right? Although they're very, very similar in the sense that there is a 0, 1, there is a AB, but the output are not similar. There is no output 1 in the first machine. So there's no simulation in between these two. We cannot find the homomorphism. All right, let's go to the second example. Okay, now we are given the state table, yeah? So look at the first one, AB, right? And output 0, 1. Show it, Shiham. The first, okay. The second table is 0, 1, 2, and also the output 0, 1. So you can easily see that we will map A to 0 because the same output. Okay, and we map the 1, 2 down there, right, to the B, right, because they have the same output 1. So M can simulate M star with that function F that goes from, we go from the bigger one to the smaller one. Yeah? 0 goes to A, 1 goes to B, 2 also goes to B because of the output. So when the output is 0, you see 0 to A. When the output is 1, you see 1, 2 goes to B. So you have down there. All right. Okay, go down. Okay, that one, I just want to show how you map the state, okay? Or the other way around, 0 to A to 0 and B to back to 1. And we can put later equivalent classes for the 1. 1 is 1, 2. All right, next example. Okay, now we have 4, yeah? We have 4. A, B, C, D, and 1, 2, 3, 4. The first one has output 0 and 1. The second one has output 0 and 1. Okay, now look at how we will match up. So we will have only later 2 states because we will group the output 0 with the 0, the output 1 with the output 1. So down there, okay, 1 goes to A with the output 0. Okay, 2 goes to D, 3 goes to D, 4 goes to D because they all have output 1, right? So you match up down there, from down there to up there with the same output. So 0 goes to A, 2, 3, and 4 goes to D. You might be thinking, what happened to B and C? Then it's actually grouped with the same output, A, B, C. A is the representative. Okay, so just pick the smallest one. The next one is the other way around, from top to bottom for the G. So A with the output 0 goes to 1. B also goes to 1. C also goes to 1 because they all have output 0. A, B, and C have output 0. Go down there and see who has output 0, which is 1. All right, and only D has output 1. So you can pick the smallest one down there. So we pick a 2, right? 3 and 4 is missing there because it's lumped to 2. All right. Next. All right, this example, the question is to construct a table and a state graph of a quotient machine given only the M. Okay, this is a very common question that we will only be given one machine and we have to come up with the quotient machine M star. Yeah, and we have to define, like before, to define the existence of this G and prove the homomorphism, meaning we have to prove the property. All right, so this is given. Yeah, look at the table and list in your mind what is your S, right? So S, show the first column, is consists of A, B, C, D, and E. All right, that is S. Now your input is 0 and 1, right? Output is 0 and 1, and you have the next state. Now, follow this step to get to the machine, the quotient machine. All right, first, we partition the state with the same output. Okay, so look at the output, there is a 0 and 1. Write out output 0. So output 0, look at the left, that will be A and C. Put down there as a set. Yeah, that is how we get the first one. Now we go to the output 1. Look at the output 1, B, D, and E. So you put B, D, and E down there as the set for output 1. Right, that is first step, just to put together the output that are the same. Next, check whether the next state under the next state in the middle is in the same block by inputting 0 and 1 to the element in the block. So we will see this already block means the AC and the BDE. Is it okay? Is it in the same block? Yeah, I don't want you to move, Shiham, just focus to the table. Look at A under 0. It is a C, right? The next state, yeah, it is a C. So C is in the same block. C is in the same block, yeah? Look at A under 1. It's A. So it is in the same block, meaning it is okay. We can replace later with ACA under just the bracket A. Look at now the C, okay, the purple C. It's AA, right? AA. So this is okay because A and C, they are in the same block. Okay, so later on, when we do the next machine, the next table, the A and C, the purple one, we will just call it bracket A, right? Bracket A, you don't have to write because later you will see it. Just understand now, bracket A, and on the right is all bracket A. Yeah, so you will have only one row. Now look at the BDE. Okay, remember BDE as one block. Look at the B. On the right is a D, is okay. It's in the same block, but under input 1, there is an A which is not the same block. Okay, hold on to that thought, meaning you have to separate. You have to separate the B from the rest, okay, because it is not in the same block. Okay, now look at D. Under D, the next state is D and B, which is okay. All right. Under E, E and B, which is okay. So the one that is not okay is the B. All right, because of the A under current input 1, because of that, it's not in the same block. That is why step 2 is to check whether the next state is in the same block by inputting 0 and 1 on top. Yeah, okay, next. All right, so this is what I've been mentioning before. Okay, the input A, the next state is C, which is in that same block, right? Just now, C also A, which is in the same block. The next state under 1, also A and A, which is in the same block. So we are okay under block AC. For block BDE, remember just now, the BDE, the next state, yeah, under input 0 is okay, right? They are all in the same block BDE, but under input 0, under input 1, under input 1, the B goes to A just now, right? The one that I said is a problem. It's a different block. So you see, if it is a different block, you have to partition again. Break that into 2 partitions. So DE is okay, but B you have to partition again into B and then DE. Then we get the equivalence classes. A, which is AC, B, which is B only, and D, which is DE. Yeah. Then from the original, it should be small letter, yeah. A, B, C, D, E. Okay, on the left. A, B, sometimes the word they change, right, to capital. Okay, so A and C becomes equivalent class A, B becomes by itself equivalent class B, and D and E, they are okay into equivalent class D, not C, yeah? D. Okay, D. All right, so that is our G. You can put the G in the middle of that. Okay, so that is how we get the first state A, B, C, D, E into A, B, A, and D, D, right? Because we only have D and E goes to D, C and A goes to A, B goes to B. That is our homomorphism. And from this, we get this table that I mentioned earlier, remember? I said A and C, you block into A, and on the right is also AA. B, you can put D, and the problem is solved before because B goes to A is okay, and the rest D and E goes to D and B. So this is a nice, actually, quotient machine that is mapped from the previous machine. Okay, next, last one. Okay, just draw the state graph as before. Okay, and next. Okay, and this one is to prove it's a homomorphism. So we don't have time to go through one by one slowly, but do it as before, yeah? put the S, A, B, C, D, E, and then the output, and from the G, and find the F star from the second table, and show that these two are the same, the column are the same. The second one, you have to go SI, so A1, A0, A1, B0, B1 until E0, E0, E1. Okay, the next one is the FS, S of I, and then the G, right? You can do either way. You can do right first or left first. Just now I do the GF is the second row, right? It's second column, right? Now I do it in the third one, but it's okay. Just as long as you can show that two of these columns are the same. If you partition wrongly, G is wrong, you won't get this. So be careful with the steps. All right, last one. Habis. So I would suggest when you go back to this particular problem and rewrite and see how you get to this point. Okay, and go to, after this, we finish all this, go through the exercise. Yeah, some of them are very straightforward, and go to the last one, because the last one will give you the construct a state graph, right? In exercise 4, you are given 2 already, machine, but try to match up the machine, okay? Even from M only, you can get the quotient machine and come out. You see, for the first one, 0, 1, 2, 3, 4, that is the output, right? 0 and 1, so you just partition and see if you need to partition again, all right? So until now, Shiham, thank you very much for your help. I won't be as fast as you, that's why I'm still old-fashioned with my whiteboard. Okay, I'll stop